In this video 4-2 we will be looking at patterns of their linear functions. By the end of the video and work time in class, you should be able to say I can identify and represent linear functions. In a linear function you'll have a dependent variable that changes in response to the independent variable. That independent variable affects the dependent. The input is the independent. That is your x. Remember that. The x is your input. The independent, where the y is your output. That's the dependent variable. X is the independent. Y is the dependent. In the diagram below, what is the relationship between the figure number and the number of squares in the figure, and how can it be represented? So we're starting to get here into linear functions, and what we need to do is look at the relationship between the figure number and the number of squares in that figure. So we look at figure 1 has 5 squares, figure 2 has 9 squares, figure 3 has 13 squares. And what we want to do here is look for a pattern in the data. If you see from 5 to 9 it's going up by 4. From 9 to 13 it's going up by 4. So if that's the case, if I were to go backwards, then at 0 this would have been 1. Because once again, this pattern I'm going up by 4. So from 1 plus 4 gives me 5, 5 plus 4 is 9, 9 plus 4 is 13. And this gives us a linear equation that we can represent this data from, and it is y, which is the number of squares, equals 4x plus 1. So I'll explain here. I get the 4 because that's the constant change. That is your slope that goes in front of the x. The plus 1 comes from what it originally started at. That's at 0 when x is 0. So 0, 1, and then it constantly went up by 4. See, now if we checked our work, let's say we take 2. Put 2 into the function right here in for x. 4 times 2 is 8, and 8 plus 1 is 9. And when we put in 2, we get out 9. Once again, the x, that would be this 0, 1, 2, and 3. Those are the independent variables, the 5, the 9, the 13, and the 1 up here also. Those are the dependent. They're dependent on that x value. A function is a relationship that pairs each input value with exactly one output value. Very important. Each input has one output. Each input has exactly one output. When we have a linear function, it's a function whose graph is a non-vertical or part of a non-vertical line. The table here shows the amount of water, y, in the tank after x minutes of being drained. Is the relationship a function, and describe the relationship using words and an equation. First of all, is the relationship a function? Does every input, if we look at our x's, is every input, 0, 1, 2, 3, have exactly one output? We see every input has exactly one output. So, yes, this is a function. Describe the relationship using words and an equation. So what we look here is we look for a pattern. We know our inputs are going up by 1 over here. So this is constant, which is good. We see this is all going up by 1. Now let's see how the values over here are going up. Well, they're going down. And this is making sense because the water is being drained. And we see that it's constant. It's constantly going down 12. Specifically 12 gallons it's going down for every minute. So the amount of water is going down 12 per minute, and it started at 440. So this 440, we see when x is 0, the amount of water is 440, so that's where it started. It started at 440 gallons, and every minute now it's going down 12 gallons. And so this right here would represent that relationship. And so in words, I would say the amount of water started at 440 and went down 12 gallons per minute. You could also write this function as y equals 440 where it started and it went down 12 per minute. So this would be the same thing. Can you say I can identify and represent linear functions? Write a summary and a reflection and be prepared with any questions for the work time in class.